looking at the telescoping series test. And I prepared for you an example over here. But before we get to the test, we're just going to talk about when you should use a telescoping series test. So we already know that a telescoping series generally looks like a fraction minus a fraction, and we know that if the nth term approaches 0, then the telescoping series will converge to some number. Now, on a test, you're probably not going to see a series that looks like a telescoping series. You're probably not going to see a fraction minus a fraction that can be recognized as a telescoping series. You're probably going to see something that looks more like this. So a constant over a denominator that can be factored. And we need to be able to recognize when we should use a telescoping series test. So remember that usually if there's a constant, so 2 in this example, 2 in this case, over a denominator that can be factored, so 4n squared minus 1 can be factored into 2n plus 1 times 2n minus 1. So if we have a constant over a denominator that can be factored, then you should use the telescoping series test. So now that we figure out that we can use this test, the first thing that you want to do is convert this into something that looks more like our traditional telescoping series. So we want to make this two fractions that are subtracted from each other. So the way that we do this is we use partial fraction decomposition. So the first thing you want to do is rewrite the first fraction that they give you. And it's equal to some constant over the first factor plus another constant, b, over the second factor. And we already know that the first factor is 2n plus 1, and the second factor is 2n minus 1. And you can switch them up, it doesn't really matter what order you put them in, you'll still get the same answer. And also it's important to keep in mind that if you have a factor that is not linear, you're not going to have a constant up here, you're going to have a linear series. So if this is a quadratic, then you have a linear up here. If this is a cubic, then you have a quadratic up here, and so on. So in this case, it's pretty easy. They're just linear, so it's just going to be a constant. So now we are going to multiply by 4n squared minus 1 so that we can get rid of the fractions and just get easy numbers. So we get 2 equals a times 2n minus 1 plus b times 2n plus 1. So there we have that. And now we want to solve for both a and b. So we have to cancel one of these out. So we have to get 0 here so that we can solve for b, or we have to get 0 here so we can solve for a. So the way to first we're going to start off by making this 0, and we want to make this 0, and we can do this by making n equal to 1/2. So then you get 1 minus 1 times a, so then that just cancels out to 0. So let's try it with n equals 1/2. So you get 2 equals 0 plus b times 2 times 1/2, which is 1 plus 1. So 2 equals 2b, and b equals 1. So we have our first constant right there. Now we want to make this equal to 0 so we can solve for a. So in this case, we're going to make n equal negative 1/2. So we get 2 equals a times negative 1/2 times 2, which is negative 1, minus 1, plus 0. So 2 equals negative 2a, and a equals negative 1. Now we solve for our second constant. So now we can rewrite this telescoping series, this fraction, as a telescoping series that we can easily recognize. So we're going to write it as a sum from n equals 1 to infinity of a, or let's start with b in this case. So b, so 1 over 2n minus 1 minus 1 over 2n plus 1. And the only reason that I switched these two is because it's easier to see the telescoping series if you have this one first, because then you get this one minus this one. Otherwise you would get minus negative 1 over 2n plus 1 plus 1 over 2n minus 1, which is the same thing, but it's easier to see that this is a telescoping series like this. So now the way that we figure out whether or not a telescoping series converges or diverges, and if it converges, what it converges to, is we have to start writing out a few of the first terms and see if they cancel. So the first term is going to be 1 over 2 times 1 minus 1, so 1, minus 1 over 2 times 1 plus 1, so 1/3, plus 1 over 2 times 2 minus 1, 1/3, minus 1 over 2 times 2 plus 1, 1/5. And you can keep going if you want, but I'm just going to stop there because I can already see that 1/3 and negative 1/3 cancel out. So I can already see that everything past here is going to cancel out, and then the last term is going to approach 0. So we know that the sum is going to be just this term, and so the sum is equal to 1. So here we've proven that this telescoping series converges to 1.